Okay, so I just want to give a brief introduction to myself. I'm Jon Lund. I'm a strategic advisor to Micantis, who is a company that builds a data platform for helping centralize battery data with main objectives for driving your productivity, decisions, and helping generate business value. A little bit more background about myself, as I have previous years of experience going through the battery qualification side of things, running around helping develop the Micantis platform, along with also doing process improvement across internal manufacturing and external manufacturing. And today, what I'm going to review is how breaking down these data silos help you drive cost reduction. So let's get into it and dive in farther. So what I want to take away is this presentation is going to be thought-provoking. It's going to help provide some inspiration to organizations, along with seeing the possibilities and enabling opportunities. What that's going to look like is we'll review the state of organizations today, just to level set the tone, review how we're going to centralize battery data from a high level, and then what that does to your business and what it enables. Let's look at organizations today. From a BCG assessment back in 2024, only 8% of organizations were classified in the highest category of data maturity. What that means is there's 90% of companies across the world that have opportunity to improve, and on top of the 8% that can always be doing better. So what does that mean? We have room for improvement to help get to where we need to go to make these actionable decisions. From another Salesforce study, right? 62% of leaders say they can't integrate their data streams and data systems to use for AI. Why do I mention that? AI today is a buzzword, whether you love it or you don't like it, but it's still the gold standard of how we can get with our data to drive further productivity across our operations or companies. And then from another survey from McKinsey from this year, 39% of leaders said one of the biggest barriers was these breakdown of data silos and change management. What does it all mean for us, though, is that there's opportunity to get more potential from our data and drive business value. So going ahead, I want to break this down for you a little more. What I pulled on this slide is you're going to see a few different functions within an organization, spanning from your product management side to your manufacturing side. Each one has their own KPIs that are targeted for those functions to help them drive that operational efficiency. But sometimes what that does is it means they accidentally compete against each other. How many times are you in a meeting or you have a decision to make and you don't know where that data lives? You couldn't get access to it because it was either stored on someone's local C drive, maybe it was an Excel doc, a Teams, or was stored across the world and I had to email someone for 3 weeks trying to get it. I think we've all been there. We've all had the pain. And what ends up happening in this case is these KPIs can compete against each other. So for reference, let's talk about a supply chain item. It came up a lot throughout our panel that we talked about and listened to just prior to this, right? My supplier shipped something to me. I want to do a cost down because my supply chain got disrupted through maybe it was a war or during COVID, and I just had to flip suppliers. Maybe it was more expensive or less. Okay, I pass it downstream to my manufacturing team. Maybe there's some data flow on what I changed. Maybe there's not. Then what happens here is my manufacturing team goes and builds it. We think everything's the same, but my quality team flags an issue, and that data is selectively flowing between, but we don't necessarily know what changed. Right? We've all been there, and we've all seen some of these issues come up with how the data flows, and when it's siloed, we can't all access it or make decisions quickly or effectively. What that gets into is how most of the real value of all of our data and how the centralization is going to play out is it's going to help us generate smarter business decisions. And at the end of the day, from a financial performance standpoint. So what I want to get into now is what centralization of our battery data is going to look like from a high level and what it'll do for our organization. So when we're looking from a holistic level, at compiling data across an organization, from personal experience and seeing how this is played out and integrated, it's really good to start with where do I want to store it. Cloud locations are generally a very valuable option. Maybe it has to be an on-premises storage for the teams that need that for whether it's certain government aspects or they prefer that method. But having that centralized location where you want to pipe it to is going to be your biggest first step. From there, it's what information and how do I want to do that. Whether it's from data loggers, if I'm an operations site with a lab or testing, or maybe it's some manufacturing data coming off my line. Have it structured with standardized organization and naming. You'll see why this is important later for the enablement opportunities that I'll cover in a few slides. Whether it's your metadata, right? This could be some pass-fail data, whether I'm doing testing end of line, maybe I'm doing a cell teardown for an evaluation from the engineering side, or I'm just taking some notes and I want it structured in a file that can be embedded in a database. Then there's also the human file uploads. So maybe it's some Excel sheets you have or things like that. But what we want is to just make sure it's structured with a standardized format, which makes it repeatable. And you'll see once again the benefit of that later. From an IT side, it's making sure everything you need is equipped and can be transmitted to this location. Because we all know at the end of the day, it's always that one piece of equipment that you want and you don't have access to that causes some of those bottlenecks. One of the other bottlenecks that you might run into also, if we start chasing after the centralization of data, is making sure bandwidth pipelines are okay. Depending on the country or the op sites, sometimes there will be bog down rates and you have to throttle the data out depending on your operation size. But what does this mean? All of this, these steps in how we're ingesting all this data helps lead to that standardized structuring. And it's core to all the enablement opportunities and where I'll show you from the value creation as we move on. So on that second content slide, I discussed the silo data. Well, now once I have this central cloud location and how it's stored or whether it's on-prem, now I can get these KPIs where they start actually complementing each other. So that same circumstance I talked about before, the supply chain, the material coming in changed, right? But from a supplier side, maybe I'm looking at my supplier pricing. I do want to note all the KPIs I have on here are just some very selective ones, and your orgs may have dozens or multiple that are more important, but generally these are some of the big ones from my past experience. But when we look back at that situation from before, let's say the material changes. Well, now my engineering team, my quality team heard about it because we see the change come through the system, which means now when I go test it, I can test it historically against all my past test results of whether it's various material suppliers, cell suppliers, or if it's an end-of-line test and we want to see what's changing throughout the whole value stream. The data can now easily flow between teams, so maybe I won't have an end-user risk. Or my product management team now isn't complaining how I had to pull product off the shelf, which is impacting their revenue and growth. Or my manufacturing line didn't have to stop because we have to go figure out what we just built, or we have to put all these quality or throttle checks in place that will lower my throughput and potentially increase my scrap and defect rate. That's how we go from silos to using a centralized data stream to pass it and build transparency. And you'll see where this even comes into more play as we keep going along farther, which is where the actual value lies in generating a business value. So if I go ahead and take that example that I keep referencing from the beginning of where's my data, it's stored across the org, I don't know where it lives. I assume all of you once kind of had that pain where it's living on someone's local computer, whether it's an Excel sheet, a Teams doc, an email, or it's between 10 different people in various locations there, or once again, it's across the world. So I don't always know if it's accurate or can it get there? Can I get it? Can I make the decision? How long it's going to take? I've been in this situation before, and I bet some of you have. That executive comes to you and they say, I need a decision end of day, pull me the data on it. Or I need to make a product decision for building for a customer. Can you get that for me? And then you start this rabbit hole of all of your questions of can I actually do that? And is it a reasonable request? Right? We took that centralized data and put all of our information in that location from a few slides ago. And what after, now I have all that information. truncated by an op site, not necessarily an individual location or person, but by my operation sites into that central location, which now can flow to that one person. Where instead of maybe needing 50 touch points or emails or other phone calls, texts, I can do it myself and pull it with a good front end. It turns something that can be painful into something simple. I promise this is the last of the more mundane slides before we get to the fun part of it. But it's really important because it shows what that robust backend will look like. So what you're seeing here on the left is data from all these automatic ingested sources. This happens to be cycle data from various equipment brands and streams, but this could be from your manufacturing line. This could be from oscilloscopes, anything used from the engineering to operations side of things. On the right side is that structured and very robust naming of metadata, right? So these could be your files that you're uploading or etc. The thing I want you to notice on the slide is really look at how when I look at the naming structure, it's well defined. It can be customized to how you do it in your organization, but the point is that it's repeatable, customizable, but it's searchable, and it builds in that traceability that you might not have if you're doing things through PowerPoint, text, email, etc. When we go ahead and look at the actual use cases for this, let's look at a quality or engineering example. I want to pull data either from today that I'm testing, or I want to compare it and find it from 10 years ago. I can go easily search my database, pull up some various information, throw it on a chart that I could present out to the executive team, or an engineering review, or a product management team. You name the use case, but I can do it nearly at my fingertips and fast. What you see here is I added just a reference line for I want to see how my product performs over what my customer expects at various times throughout the journey of the product. For reference, this graph took me less than 3 minutes to make, and I added this criteria line for what I wanted the cell to achieve on my own. So that's how fast it is. Now imagine if you had to do that on your own, run to a machine, pull the data, go to manufacturing, exponentially longer. You might have to clean it. There's so many things that go on where now I can do this extremely fast and get those valuable decisions and increase my productivity, teams, or the orgs. Let's look at another one. It's a similar take, but now it's from that engineering, product management, or still also the quality side. The blue lines represent a Gen 1 product. The green lines that are nearly identical represent Gen 2. I want to compare two different, either what's a cell, maybe it's an end product that I built. I want to compare that. I can quickly visualize it and pull it, and I know it's accurate. I can see how the data is traced, what location it came from around my global enterprise. Or maybe you're a small company, but you still want to know who touched it or what machine it came from. All that gets embedded when you build these centralized platforms and build it robustly. What this also allows you to do is now I can quickly change it. Maybe I want to go and compare it against something different I didn't before. It's not this hurdle where I have to have a new meeting and I got to reschedule an hour and spend 5 hours. I would just go do this on the fly if it were me. That's how fast of decisions and information flow we can do and is transparent to the orgs. The thing that I don't show you on the screen, which is very beneficial, is when you build a proper front end to handle all your back end. I can even share this information across a text or Teams with a link that I didn't attach. Now imagine that. You go in your email or your Teams and you just send them a link to the graph you made. They can see how you made it. They can go play with the live results, whether it's from a technician level or up to a C-suite level. Now, let's look ahead what this means for teams that are building PowerPoints. It seems like everyone's built a lot of PowerPoints these days, whether it's repeatable, standardized. I'm doing an operations update. I'm doing an engineering update, or I'm doing a qualification, but I still got to report out. This is a real business case from implementation. So before there's a standardized backend, right? This is where I showed you those multiple end data locations, siloed across people, etc. 36 hours for this particular company's report. And this was in the case of like an incoming quality or an outgoing quality check. They decided they built an in-house system, but it's still, the data is all truncated. It helps speed up some items using Python or even a little bit of vibe coding. It still took 8 hours to make this report. And now you can imagine if I make one, okay, it's fine. But you start making multiple or hundreds a year as you scale as an org. This turns into thousands and thousands of hours a year spent making reports that I need to make decisions off of. You do an automated system, have that centralized back end and the proper front end. This came down to less than 3 minutes. So 99% time savings per this standardized report that I have to make every time I want to go build something. Now, when you look at it from an R&D side too, there's tons of savings in there. A lot of times, yes, analysis can be complex, but you have repeating variables or that standardized update. I don't have a baseline for fully manual, but I can tell you if it was taking 32 hours with the in-house system, it was very painful. And as some of you know, imagine plugging in USB drives, transferring data, etc., and getting it. With a fully centralized system and that proper front end again, and having these systems automated, you can do that in less than 10 minutes. And this is a complex report that came out to 100 slides, 100 megabytes of data, 99% time savings. So when you build these robust backends and you have the proper front ends to actually drive in a business setting, it makes your teams more productive and reduces the need if you want to scale to have those engineers or operations staff headcount increases. But it also allows you to really scale the business exponentially and not be bogged down in tasks that you could be using that time more spent on creative activities or really driving your teams. Now, I want to look also at how this does for an operations setting, right? For the operations teams out there. I used to report out quite frequently on how are my operations sites doing, whether it's a lab, whether it's production, etc. Maybe it's quality, maybe it's supplier performance. When I build these backends that are structured, named right, stored in these locations, I can quickly pull a global comparison. This is just a snapshot of a dashboard. I apologize for the near infinite models that get small up there, but it gives you a perspective of how much data I can pull and how I can parse it to quickly screenshot this in less than a minute or two and put it in a slide deck. Maybe it's up on a TV or it's going to the executive team and say, hey, how do we do this month? How do we do this quarter? Or I want to compare the last 5 years. That's what this is so powerful in doing when we have backends established. It once again helps speed things up and it's actionable and it helps you make business decisions. I said I'd talk about AI in the beginning during the pitch. Well, let's get to the real fun, right? This is like the golden item that everyone's chasing after today. But to get here, you really need those robust backends so we don't get that garbage in, garbage out scenario. So what I'm going to show you now is I'm pulling some data out of a backend that's structured. Happens to be called Moose AI. It's embedded in the Micantis platform. What it does is I can use it in so many ways, from writing code to visualizing things, the writing API callouts, which means I can just pull data through something that's already structured in my other systems. And I can run specific scripts. So maybe every morning I want to get a report out on what I just did yesterday from a data perspective or a machine perspective, or that urgent product I'm trying to ship that's on test perspective. So we look at this, we can submit the request. And then the back end, it's going to go parse through all that data that's structured. It knows what I'm looking for. I train it based on generalized naming schemes and the customizability for the business. And what it's doing on the left here is you see it's going to output a script, and that's going to output some more information, what I asked it to do from an analysis perspective. I can save this. And then what I can also do is, as I mentioned, I want it to run every day and give me that information. That's powerful. Imagine how much time that saves from whether you're an engineer level or you want an executive and you just want higher level information. That's what I can do when I really build those robust backends, link it to those cloud locations or on-prem, and have it done the right way where it's not scattered. Now let's look at another use case too. We all have bad data, and it goes back to that garbage in, garbage out scenario, right? The power goes out. I stop equipment, whether it's a manufacturing line or it's a cycle test or another test, because I'm doing maintenance, etc. Well, now I got to go have my team go clean that up. Or I go present up to a higher level and I go, oh, geez, yeah, this data is not good and I'm getting questions. That's just unacceptable. And so what we can do when you have these is taking back with that good and well-known data sets, traceability from that timestamp, the unique identifiers of where it came from, you can easily use AI to merge these, build the visuals, which you're just seeing there on the right, or how that cleaned up. And what that does is I could even have this run repeatedly. So every night, or let's say every week, I want to go through my databases and clean up things that I know and have it look for characters and traceable characters to know what to merge together. But what's that mean for you? It means you have that good data to make those decisions. It once again saves you time, builds productivity, and long term, it helps drive that cost down through your organization through whether it's headcount, whether it's shipping better product to customers, faster to customers, generating that higher revenue. There's so many efficiency gains and savings through the org. Another item when you have this centralized, and I touched on the API a few times already, I can't touch on enough. You have that good, robust backend, ship that information out. Use that AI to code to call the API to put it where you want it. Whether it's an MES, hey, I'm testing the product that came off the line. I want to upload that up to a build log. Okay, write me a script, upload it every X amount of time period. Or I want to ship it off and build some dashboards or that I just don't have capabilities now. Export that API out and I'll go build another environment or to a data warehouse like your Databricks. Or I want to go run a digital twin. Now I can pull out that traceable data that I built on against some other source and build it against it. Or it's more ML or AI. There's so many use cases when you have APIs, but it enables organizations to talk to these systems. And it generates so much business value you didn't even know you could do before all that data was centralized. Now, what I want to do is I want to walk through one more case. And what this is this is going to be just a general business case and what it looks like to your organization. So I talked about various parts from quality to engineering to manufacturing. But what I didn't do is I didn't add them up and put that business dollar value to them. So that's what I want to walk through and see where it actually can save companies that money and where they can see the benefits outside of just time savings, faster decisions, better product. Let's actually see what that means. Let's build a hypothetical case. I want to take headcount. Let's say like 5 manufacturing engineers. I have 5 engineers in the lab, or what's my normal engineering team. I'll take a pretty normalized rate of about 65 an hour burden cost. So this is my salary. This is my benefits. This is if I'm paying them a bonus because they're about to ship my product faster this year. And we're going to make a lot more money as a company that our customers are going to love and drive further business. But they spend 25% of their month either making those PowerPoints, pulling data, running to a machine and plugging a USB in. But these are technical staff. In this case, that is 4,800 hours a year they're spending just on data with a cost of over $300,000 burdened. That's a lot of money just to move some files around potentially when we could be doing more time savings and making better use of that time. From a manufacturing side, let's look at a potential that scrap that went downstream from that supplier change that I talked about throughout the presentation. Let's say a potential incident cost around $250,000 I'm evaluating. Whether that's raw materials, maybe that's I built a finished product in manufacturing, so consumer goods, maybe it's a power pack, something. This number could be small for an organization or it could be very large depending where you come from or what you're used to. So let's say I have 10%, 10 incidents a year that I have to evaluate. That's almost $2.5 million. That's $2.5 million I'm nearly evaluating a year. But then we talked about, and as the panel discussed, warranty and risk. Those are huge. So if I just use a $500 warranty cost, once again, for a wearable, that might be high. For a power pack, low. And if I said, let's say I have 2% coming back, we'll say 210,000 units sold. That all ends almost $2.6 million a year we're looking at in potential scrap or warranty. And then there's the testing costs, right? For the cost of quality, the cost of running from an engineering side, quality. We'll say it's 200 grand all in between labor, my material, etc. If I could reduce that analysis time because I centralize that data and have these tools in place, whether it's from AI to just having it at my fingertips, by even 50%, And that's a very conservative number from past experience. That's over headcount equivalent time savings, or over $130,000 if we look at it from only one perspective burden. If we can get ahead of our data and I can make sure that product's good before it goes into my other finished goods product and even catch 30%, that leads you to almost 700 grand a year and higher of just potential savings from catching those few items faster, making those confident decisions and getting ahead of it. If I can even reduce testing costs by 20%, because now I'm not chasing all these issues, or I'm doing faster engineering development, or I don't have to test as much because I can pull that information faster and confidently, that could be $40,000 a year in this situation. The whole point of this is even if this number might not be small or large organization, it's showing how much dollar value you get by working to get your data in a centralized location and being able to use it to enable business opportunities from whether it's data at your fingertips graphing, making reports, making better quality or manufacturing decisions, or holding your suppliers accountable so you don't have to deal with this in the future. Right? For reference, I go back to supplier and say, hey, I have other suppliers that are performing better than you. I'm either going to cut you off or I want your price reduced. Well, now that helps KPIs across not only supply chain, but it helps it across the org and these time savings, these monetary savings, this speed to market compounds across the organization. And that's really where you start driving this large end value that exponentially scales as you do. Now, what I want to do is leave it on this final slide here before I open up to anyone with questions, open up the dialogue. I'd love to get into it more. But really, the three big points I want you to take away outside of what's possible from actually driving these real enabling opportunities is how you get better decisions from having this data centralized across your org from a battery perspective, how it generates that productivity and it causes and generates large business value across different industries and across the value chain.